So we're looking at this problem, right? It's the integral from minus 3 to 3 of the absolute value of x plus 1 dx. Now, there's a couple of ways to do this problem, okay? One of them is going to be doing the integral itself in the standard way that we normally do integrals. The other one is to do a geometric argument, okay? In either case, we can get the answer the same way. Before we take either of these approaches, it's useful for us to plot the graph. Okay, so let's first plot the graph. So draw a graph, draw some axes. Okay, and we ask, what does this function do? Okay, so x plus 1, absolute value. Remember, absolute value is something that it takes positive numbers and leaves them alone, and it takes negative numbers and negates them. Okay, another way of saying that is that the absolute value of x plus 1 is equal to x plus 1 when x plus 1 is positive, but it's minus x plus 1 when x plus 1 is negative. Okay? Or figuring that out, this tells us that this is x plus 1 when x is greater than minus 1, or minus x minus 1 when x is less than or equal to minus 1. So if I were to graph this here, what I'm writing is, let me put the point minus 1 here. A linear function that does this, increasing with slope 1, and then a function that decreases with slope minus 1. All right? So the idea behind this is, if we want to think about, there's one geometric argument that's relatively simple, where we just say, okay, this is the integral from minus 3 to 3. So if I look at this area, let me make that a little better. Okay, we see that we have two triangles. Okay, in this case, we have a triangle. We just have to figure out the heights and the widths of each of these triangles. This triangle has a height of 4 and a width of 4. So area is 1/2 times 4 times 4, which is 8. This triangle has a width of 2 and a height of 2. So 1/2 times 2 times 2, which equals 2. 8 plus 2 equals 10. Easy enough, okay? So that's method 1. Method 1 just allows us to get the areas from the triangles, right? The second method is to actually do the integrals out. Now, it's hard to do the integral of the absolute value of a function, but since we have the piecewise definition, we can split up the integral into two pieces. Specifically, what I mean is, we can write the integral from minus 3 to 3 of the absolute value of x plus 1 dx as the integral from minus 3 to minus 1 plus the integral 1 to 3. Sorry, minus 1 to 3. Okay, we know that every integral we can split up into two pieces in this way, right? Now, in each of these domains, the integral is relatively simple. This is minus x minus 1 dx, and this is integral minus 1 to 3 x plus 1 dx. So now we just have to go ahead and do each of these integrals. I'll do the first one. This is, if I do this integral, I get minus x squared over 2 minus x equals minus 1, x equals minus 3, plus x squared over 2 plus x equals 3, x equals minus 1. Now we just do a plug in. So when I plug in on the top, I plug in minus 1 into x, I get minus 1/2 plus 1. When I plug in minus 3, I get minus 9/2 plus 3. That's the first integral, and if we work this out, let's see. 3 plus 9/2 is minus 3/2, and this is 1/2. So that's 1/2 minus 3/2, which is 2, which is the area we got from the triangle before, which is nice. Alternatively, if we take, we plug in x equals 3, we get 9 halves plus 3 minus x equals minus 1, we get 1 half minus 1, 9 halves plus 3, 3 is 6 halves, 9 halves plus 6 halves is 15 halves, 1 half minus 1 is minus 1 half plus 1 half was 1 half, so this is 16 over 2, which is 8, which is the thing that we got before from the area, and again, 2 plus 8 equals 10. And there we go.